So when wastewater enters a stream, and this may be regulated wastewater, or it could be illegal or illicit wastewater, meaning wastewater that's not regulated. When it does happen, when it does enter into a stream or a river, dilution and reaeration happen, and then also biological processes. And biological processes include these microorganisms, bacteria, as well as in some cases fungi. They will metabolize organic pollutants, some that are too organic, too much carbon. They're harder for them to break down, but natural organic products that are produced by animals, fecal matter and so forth, that can be broke down also by these microorganisms. Bacteria are one group. Again, I mentioned the fungi, and then there are other organisms that once were called protists, and some people may call them small animal-like organisms. They will eat the bacteria also, and they'll convert them to substances that are less harmless or harmless. Also, these processes are somewhat dependent upon the availability of dissolved oxygen. So there are two steps, sometimes anaerobic and then aerobic. Those processes can influence how quickly we're able to metabolize pollutants. And it is generally presumed that more dissolved oxygen in the environment will promote greater or swifter metabolization of the pollutants by the stream ecosystem. So in this image here, we've got an example of a regulated pollutant source, a sewage treatment plant. The sewage treatment plant discharges its waste to the stream, and this could happen either intentionally or through an accident, such as a flood, a combined sewer overflow event. So it goes into the stream. Notice above it, it calls it clear, clean water. So this is above the pollution zone. And then down here at the bottom, we've got the recovery zone. In between, we have pollution zone and active decomposition zone. And there are a few different names for these. You might hear of them the zone of pollution or the zone of degradation. That's our pollution zone. So what happens? So the pollution comes into the pollution zone. The BOD, the demand for oxygen, was relatively low. And in the pollution zone, these microorganisms are living in the stream, and some new ones may come in too. But the ones that are living in the stream, they get this. This is like food to them. Oxygen levels go down because the demand for oxygen goes up. BOD goes up, DO goes down. Does that make sense? So BOD goes up, DO goes down in the pollution zone. Then, as decomposition really gets underway, and there's really not a lot of oxygen left. These microorganisms have used it all, and as they've used it all or used a lot of it, there are other microorganisms that are called facultative anaerobes that can continue to do decomposition even without abundant oxygen or even little to no oxygen. So low oxygen concentrations dominate this environment. Life in the stream is restricted to species that tolerate high organic content and low DO. So this is not a good area for the high oxygen demanding fish species and so forth. Eventually though, as we go further downstream, and this varies from stream to stream, your DO levels will start to climb back and the BOD levels will start to return to normal. And when they have fully returned to normal, our BOD will be close to, in this image it's slightly higher than what we started with. It will be closer to where we were at, and then the DO should be back to approaching what clear, clean water looked like above the pollution source. So the process here, this is this stream waste plume. This stream waste plume, you think of like a plume of smoke from a smokestack. Well, this is a plume in the water. This plume here, okay, this represents the assimilation occurring. And eventually you get far enough downstream, you may not even be aware that the pollution event occurred. So we're going to review these more specifically here. Which zone of these three important zones has the highest BOD? Which one has the lowest DO? So we can see on our image that the lowest DO is achieved during the active decomposition period. So it falls during the pollution zone, but during the active decomposition, that is where DO is the absolute lowest. And BOD, the demand for oxygen, it's kind of at that boundary between the pollution zone and active decomposition zone. But DO definitely hits rock bottom in that active decomposition zone. That's kind of where it gets the worst. The degradation zone, or also the zone of pollution or the pollution zone, it's that area that's right where the pollution is at, where that outfall happens. Here we see the DO decrease, you see a lot more suspended particles, sludge accumulates in the bottom, and then there's less fish and snails, and worms tend to dominate. So aquatic worms and midges are usually not viewed as clean water indicators. They are about the only thing that tolerates that environment, and since there aren't fish there to eat them, they can thrive. Okay, so this is that pollution zone. The zone of recovery is below the decomposition zone. So here's the degradation zone, is the pollution zone. These slides may be a little out of order. All right, here we go. Active decomposition zone is the next zone after the pollution zone. Here, the DO might go as low as like 0, so there's no oxygen for fish. It has a high turbidity. It smells bad. The oxygen has been stripped from the sulfates, so you'll smell the hydrogen sulfide gas, that sulfur sewer gas smell. No fish, and worms and midge flies may exist. This is the poorest water quality zone. So the pollution zone is not the poorest water quality zone. The area where the active decomposition occurring, where it smells like sewage, that is the zone. If you get into the sediments and stir them up, that hydrogen sulfide gas will be released and it doesn't smell good. Okay, so that's the active decomposition zone. After that, we have the zone of recovery. The zone of recovery is when the stream looks like its original state. The dissolved oxygen levels increase, the odor goes down, we've got what are called our type 2, our intermediate water quality taxa. They are back. Fish and game and everything else are back to normal. So hopefully after the end of the zone of recovery, we have a clean stream again. So there are a variety of factors that influence whether or not this stream is going to respond quickly or slowly. Some factors that influence it is, what was the quality of the stream like before it got polluted even more? The DO concentrations upstream and the BOD upstream influence how this stream will respond. The stream can only tolerate such a load of pollution. Also, water temperature. So if the water is too hot or warm, it may not respond well. And then also when it's cold, it may respond differently. The DO of wastewater and the BOD of the wastewater. So what's it like with what's coming in? Is the pollution really, really strong? Does it bring in a very high demand for oxygen? Is the wastewater warm? And then how much wastewater? How much happened? And how much water is actually in the stream? A small stream is more likely to have a hard time assimilating a big slug of wastewater. So all these factors influence how well that stream will respond. Now we know that streams do better than lakes. Lakes, as you remember, cannot flush out like rivers and streams. We talked about the Lake Washington example. And the nutrients can build up in a lake a lot quicker. So nutrients related to agriculture and sewage waste will build up. So we're talking about nitrogen and phosphorus building up in those streams. So we're going to stop this here and we're going to review the river stream waste pollution assimilation videos.